Hello everyone, welcome to the lecture series for the subject Strength of Material. So I am Dr. Gyanendra Marapusti, Assistant Professor, Department of Civil Engineering, SR University, Koran. So in last class, we had discussed about the columns and about the struts, and we have discussed all these theory parts. So whatever the fundamentals of the columns and struts, we have discussed about the types, its end conditions, and also we have also gone through the Euler's theorem for evaluating critical loads for long columns, and we discussed about the different end conditions and what would be the equivalent length according to the end conditions, and slenderness ratio, and Euler's critical stress, or the limitations of Euler's theorem. So today we will discuss about some of the applications of Euler's formula. So in the next class we will go through some problems related to the application of Rankines formula. So as we all know, Euler's formula is used to calculate critical load of a column or strut. So the formula we are going to use to calculate the critical load, that is PE is equal to pi square EI by L square. E is Euler's critical load. E is your modulus of elasticity. I is least moment of inertia of section. So this is carefully need to find out the least moment of inertia. If it is a symmetric section, so what would be the moment of inertia? If it's unsymmetric, we need to find out the moment of inertia about two different axes, and then to determine which one is the least moment of inertia, we have to use that in the formula. So LE is equivalent length of the strut that can be decided based on your end condition. So to solve this, we need to first write down what are the given data. So your actual length is given 5 meter, which is what's called 5 into 10 to the 3 mm. So what else is given? T is equal to 40 mm. That is the unit. So let's just consider 40. So what other values is given? So E is given 200 gigapascal. It is 200 into 10 to the power 3 Newton per meter. So the cryptic load as per Euler's formula is pi square EI by L square. So E is given. So now we need to find out its moment of inertia. So for moment of inertia, circular section, you know the formula is pi by 64 into d4, which is pi by 64. The diameter is 40 mm, so 44. So you calculate this, you are going to, when you are getting 40,035 mm. So next is equivalent length. So equivalent length, you know, based on your end conditions, one end fixed and other end free, LE is equal to 2M. So here LE is equal to 2 into L is 5 into 10 to the power 3. It's nothing but 10 into 10 to the power 3. So if you put these values in Taylor's critical formula, so pi square into E is here 200 into 10 to the power 3 into I, that is 40,000 pi divided by 10 into 10 to the power 3 to the power 2. So if you solve this, you get a value of 24 get from you to calculate this, you get 2480 Newton or 2.48 kilonewton. I hope you understood this problem. So you know what you need to do. We know already the formula, Taylor's formula to find out the drifting law. So you need to find out the moment of inertia and the equivalent length. Just put these values in this equation, we get drifting law. Next, coming to another problem where a timber section, a timber is used as a column. The section is given 15 centimeter into 20 centimeter and the length of the column is 6 meter long. The end condition is given, both ends are fixed. If the Young's modulus of timber is given 17.5 kilonewton per meter square, so we need to find out what is the drifting load of the column, and we need to find out again the safe load that the column can carry if the factor of safety is given 3. So here is the graphical representation of the timber column with the end conditions, both ends are fixed, and each dimension is given 15 into 20. And the end conditions, so based on the end conditions, your equivalent length is L by 2 or 0.5 L for the end conditions, both ends are fixed. So to solve this, so we need to first write what are the given data. So given data is the dimension of the cross section 15 centimeter into 20 centimeter. What is actual length? Actual length L is equal to 6 meter. We can write 6,000 mm. What others data is given? Young's modulus is E is given 17.5 kilonewton per mm square. So what is crippling load? The first you need to find out crippling load, right? Crippling load. So crippling load, find out crippling load, the formula is P is equal to pi square EI by LE square. So LE is your effective length as we have discussed. Here the LE is L by 2 or both and fixed. So is equal to 6,000 divided by 2, 3,000. So next, we need to find out least moment of inertia. So critical load P is equal to pi square EI by L E square. So E is there. A we have calculated. We need to find out this least moment of inertia. So let's see, this is the cross section. So if you draw the x-axis here and y-axis here, so first we calculate Ixx, that is nothing but your moment of inertia about x axis. So what is the formula for this? So suppose your B is 15 centimeter, your D is 20 centimeter. So the formula for the rectangular section, moment of inertia for the rectangular section is B dq by 12. So here B is 15 into D is 20 q divided by 12. If you calculate this, you will get 10,000 CO4 or 10,000 into 10 to the 4 ml4. Similarly, find Iyy, which is nothing but moment of inertia about y axis. So what is the formula here? Iyy is equal to d bq by 2. So here d is 20, p is 15q by 12. So get value 5624 cm, which is 5624 into 10 to the 4 mm. So if you compare this Ixx and Iyy, right, since Iyy is less than Ixx, so the value of Iyy is 5624 into 10 to the 4 mm4, and the value of Ixx is 10,000 into 10 to the 4 mm4. So Iyy is less than Ixx, then hence the column will buckle in which direction? In the least moment of inertia direction, in YY direction. So I is equal to least moment of inertia is IYY is equal to 5624 into 10 to the 4 mm4. So now we calculate the value of P pi square by B square is equal to pi square. The value of E is 17.5 into 56 by into 10 to the 4 divided by 2000 square. The value you are getting 1.107948. I hope you are getting this value. So here we got the 15 value of 15. So the second part, what it is asked? It is asking to determine the safe load for the column. So here the factor of safety is given 3. So the safe load is equal to crippling load divided by factor of safety. So what is the crippling load? 1079.48 divided by 3. We get 359.8 kilonewton. 60 kilonewton. So I hope you understood this problem. So here slightly changed. The section is rectangular section. So you need to carefully find out the least moment of inertia based on the axis x and y. Then you can decide which axis is giving the least moment of inertia value. So based on that, your buckling failure occurs in that direction. So for that, you get the least moment of inertia, and based on your end conditions, you calculate the equivalent length and put these values in the Euler's crippling load problem. You get the crippling load and put the safe load. So it is the formula is given to crippling load divided by factor of safety and get the safe load. You write the given data. So what are the given data? So to find out from the question, original length L is given 4 meter, 4 into 10 to the 3 mm. External diameter is equal to capital D is equal to 40 mm. Internal diameter small d is equal to 25 mm. So deflection is given. Deflection L 4.8 mm under a tensile load. Tensile load is given 60 kN P. So you need to find out the buckling load and the T, and you know the formula is pi square E by y, which is 0, and the cell. So we find out cell load factor of safety is given 5. So the first step is to find out. So you know the formula pi square EI by AB square. Let us just find out E, modulus of elasticity, E. So E, you know the formula. E is not given in the question, you need to find out. So for that, you know the formula sigma by E, stress by strain. So to find out stress, you need to calculate area, that's load by area. To find out E, del 1 by A. So the extension is given. We find out E Let us just find out the area of the section, area of the tube, area of the tube. A is equal to pi by 4 capital D square minus small d square. So we calculate this pi by 4, 40 square minus 25 square is equal to 765.8 mm square. So the area of the tube calculated 765.8 mm square. So now we can calculate sigma is equal to E by A, 765.8 divided by, sorry, this P is 60 divided by 765, so we take the 3, 60 divided by 3, 765.8 square. So this is sigma. So then I calculate the strain, that is del L by A. Del L is given 4.8 divided by L is 4 into 10 to the 3. So this value are getting 0.001. So E is 60 into 10 to the 3 divided by 765.8 into 0.002. So we are getting a value of 65290 Newton per mm square. So here it is mentioned in the question the end condition. So end condition is, now we calculated this E value for this formula. So let us just calculate this end condition. So equivalent length. In the end condition, it is both end E. So for that condition, air E is equal to air is nothing but 4 into 10 to the power 3 m. So next, we need to find out this moment of inertia of the tube. So this moment of inertia tube I is equal to pi by 64. This is the Fowler section. So capital D4 minus small d4. We know this formula. So pi by 64 44 minus 44. This value we are getting 10,106,500 mm. So now if we put all these values, E we have calculated, N E we have calculated, now moment of inertia is calculated. So we put all three values in Taylor's particular formula is pi square into E r by N square, that is pi square into the value of E we got 65290 into 106,500. So the inertia divided by N is 4 into 10 to the 3 square. So this value is 4290 Newton. And we can write 4.29 kilonewton. So the second will be just self load. That's discussed in the last question, which is crippling load divided by factor of 7. So it's equal to the crippling load is 4.29 divided by 5 into 0.858 kilonewton. I hope you understood this problem. So similarly, so next question is, suppose you need to calculate the chef compressive load on a hollow cast iron that is used as a column, and the end condition is given: one end is rigidly fixed and other end is hinged. So and the other data is given: the 15 centimeter is the external diameter and 10 centimeter is your internal diameter, and 10 meter is the length of the column. So you need to find out the safe load by using the Euler's formula, with a factor of safety is given 5 and Young's modulus is given 95 kilonewton per square. So here is the graphical representation. The external diameter is 15 centimeter, internal diameter is 10 centimeter, the length is 10 meter, and the end condition is one end is fixed and other end is hinged. So for that, your equivalent length is 0.7 L, 0.7 L or L by root 2. So to solve this, let us write what are the given data. Your T is 15 centimeter, small d is 10 centimeter, your actual length L is 10 meter, 10 into 10 to the 3 mm. Factor of safety is given 5. Young's modulus is given 95 into 10 to the 3 Newton per mm square. What else? That. So next, let us find out moment of inertia. Moment of inertia of the column. I is equal to, you know the formula, pi by 64 capital D fourth minus small d fourth. If you calculate this, pi by 64, 15 fourth minus 10 fourth, if you calculate this, it is coming 50625 minus 1000. We solve this, we are getting 1994.175 cm fourth, or 1994.175 into 10 to the 4 mm fourth. So what is the end condition is given? End condition is one end is fixed, other end hinged. So for equivalent length, for this end condition, L by root 2. So now if we use the Euler's crippling load, P is equal to, you know the formula, pi square EI by L E square. So now put the value pi square into E is 95 into 10 to the power 3 into I, we have calculated 1994.175 into 10 to the power 4 divided by L is your 10,000 divided by root 2 square. So if you solve this equation, you will get the answer 373950 Newton, or 373.39 373.95 373.95 kilonewton. Now I need to find out the safe load. So the formula for safe load is crippling load divided by factor of safety is equal to 373.95 divided by factor of safety is given 5. So if you calculate this, I am getting 74.79 kilonewton. I hope you understood this problem. So this similar kind of problem you can now solve. So some dimension is might have given, and the other value required is your modulus of elasticity. So the important point is you need to find out the moment of inertia based on the cross section, and you need to identify what is the end conditions, and based on that you can calculate the Euler scripting load, that is E is equal to pi square EI by L E square. Okay, so thank you, we'll meet in the next class.